These are the lectures for Module 4. We're going to talk about basic Java again, arrays, and start to talk about methods and coding techniques. Those two topics go together well because once you start talking about methods, you start to ask that horrible question, when do I need a method? How do I create a method? That gets us into coding techniques. As usual, here are the outcomes. Go back afterwards and convince yourself you have achieved these outcomes. And then let's get into this discussion. Before we talk about arrays per se, let's talk about data types and data structures and what the difference is between the two. You've already used data types. You use them in your declarations. So you say int x, or you say double x, or you say boolean x. And what you're doing is specifying the type of data that that variable or attribute is associated with. But what is a data type? We've used them, but what are they? A data type, the definition that I like, it's a set of values and associated operations. So when you say something is an integer, what have you done? You've specified the set of values that that variable can take on, or that attribute can take on. And you've specified the operations that can be performed on it. Same thing with Boolean. You've specified that the values are going to be true or false, and you've specified that the operations are and, or, and not. So the data type is telling you what values you have, what operations you have. Also, when you declare a data type, you're telling the computer how much memory to assign to each variable or attribute, and you're also telling the machine how to interpret a particular string of ones and zeros. Remember, everything in the computer is ones and zeros. If you just looked at the ones and zeros, you wouldn't know a character from an integer from a double. So they have to be interpreted differently. And by declaring the type, you're telling the computer how that interpretation occurs. Data types may be primitive. Primitives are the ones that are directly associated or directly supported by the programming language. And they tend to be thought of also as only holding a single value. Like when you say int x, that x can only hold a single integer value. When you say double x, that x can only hold or be associated with a single double value. These are the primitive types. Every programming language gives you primitive types. From those, you can create more complex types. So you can compose larger data types. In C, these are structures. In Java, it's classes. A class is really a type that you've defined. That's why they're often called user-defined types. So that type, it's kind of a funny word until you get used to it, but the data type of that class is its class name. And it's not primitive, it's complex. It contains multiple attribute values, most of which will probably be primitive. And it also contains methods. In other words, it contains a set of values and operations. So it meets the definition for data type. Now, compared to a data type, what is a data structure? Well, once you get into the situation where you want to have more than one value associated with an attribute or a variable, then you have to ask the question, how am I going to store these multiple values in memory? And there's about 7 standard data structures. We'll talk about them later in the semester, but you've probably heard of stacks. You may have heard of queues. You may have even heard of search trees, logic trees, binary search trees, that kind of thing. And you've almost certainly heard of arrays. Array is a data structure. It's telling you how that data is stored in memory. And specifically for an array, the structure is this. The data values are stored one after another in a single or contiguous block of memory. That's the array data structure. Now, I'm going to note that that describes what a true array is. A lot of modern programming languages tell you they have an array, and they don't. They act to you, the user, as if they were an array, but they're not technically stored in contiguous memory locations. Java stores them in contiguous memory locations, and I can tell by the way Java puts restrictions on what we can do with arrays. So data types are about values. Data structures are about organization. All right, so an array is a collection of data elements or data values. Each individual one we call an element. And somehow we have to access them, and we access them using the array index. The array index is just a number, an integer valued number. And if you say 6, what you're saying is I want to see the 6th data element, or I want to assign the 6th element in the array. They have to be integer. You can't put a value in at the 6th and a half place in the array. It's either the 6th or the 7th, nor can you look at the 6th and a half element in the array. There's no meaning to that. So they have to be integer values. The head of the array is the beginning of the array. It's the memory address at the beginning of the array. And when you define an array, actually what the machine only keeps track of is where does this thing begin? Where is the head? So when you're setting up an array and you say, you know, my array has the name my array, the only thing the computer will keep track of is where's the head? Where's the memory address of that first element? And that explains how we do indexing. Because if we do a sub I, what that means is go to the head of the array and jump I memory spaces to the array element that you needed. So if you say a sub 4, a bracket 4, it's go to the head of the array and jump 4 spaces. Well, how do you get to the first element? You're already at the first element when you're at the head of the array. So you jump 0 spaces. And that's why in Java they use 0 as the index for the first element. Go to the head and jump 0 times and tell me what's there. Because they start at 0 and not 1, if you have n elements in your array, then your highest index that will make sense is called n minus 1. It is fairly easy. It is fairly easy to accidentally try to index things that are off the end of the array. So if I had 20 elements in my array and I tried to index number 20, that would be wrong because 19 is the highest value I could use. Or if I try to index number 48, that would be wrong. Or if I somehow weirdly try to index -6, what you'll get for the error message is this: index out of bounds. So again, read your error messages. If you're reading index out of bounds, almost certainly you've got some math issues where you went off the end of the array and you tried to index an array element that does not exist. Now in Java, because it's an object-oriented language, they gave you the array as an object. And this is a good thing. Since it's an object, it has pre-built attributes and methods that are available. The most useful attribute, the one you'll use all the time, is length. So if it wasn't an object, then all the array would know is where the head of the array is. And maybe how big the array is. Some languages don't even know that. But because this is an object, you know where the head of the array is, and Java will keep track of the length. And that's the name of the attribute, length. So it's myArray.length. And that's very useful. We'll see how that works in for loops. We never have to, as a programmer, you never have to worry about the size of the array. You just have to, you can always ask an array, how big are you? Array.length. Because it's an object, they need declared, but in order to create the object, you also have to use the new keyword. Remember, that objects never get created unless you use the new keyword. So you can declare an array like this: int square brackets, nothing inside those square brackets, integer array is its name. That would be an array of integers. Obviously, integer array is not a great name for an array. You want to name it what its job is. You're familiar with this one, string args, because public static main string args. Well, what does that tell you? Main accepts an array of strings, and the name of that array is args. We've been ignoring that for the whole semester. We'll pretty much ignore it the rest of the semester. That array can be empty, and because we've been ignoring it, it always has been empty in our examples so far. That's just declaring it, though. You didn't create it. So how do you create it? Well, I've declared int array up here, and now I want to actually create the array. So I say, okay, integer array equals new, and then this is a little odd. You'd think it would be array, right? But because that's the name of the object, but it's int because it's the name of the type. And then in square brackets, put the size of the array. There are tricks by which you can populate the array immediately. Usually you do that if you have very small arrays. It's very rarely done. I never recommend it. I can't think of a place where it's really needed. So this format is my preferred form. Integer array equals new int 20. Now what have we done there? We've actually created a new array object. It has 20 spaces to hold integers, and Java will immediately initialize all 20 of those spaces to 0 for you. Because Java basically only keeps track of where the head of the array is, that's what integer array is going to get assigned to it. It's going to get the head location assigned to it. And what are you doing up here? When you say int bracket integer array, you're not creating the array, you're declaring the array. What are you really doing? You're putting a placeholder in there. You're saying, hey, somewhere integer array here, you're going to have, that's a placeholder where someday you're going to have a memory location for the head of the array, and it goes there. Technically the head of the memory object. You can do this, double, square brackets, another array equals new. There's that new keyword, double 1000. So this declares another array because it described the type and with the square brackets said it was an array of doubles. And not only did it declare it, it created the actual array object, new. Now, why would you declare it up here but not create it and then create it later? Sometimes you don't know what size you want it to be. So sometimes you wait to create it until you know how big it's going to be. And when we do the class example, that will become evident, the code that I have for this. Now these are arrays of primitives, primitive data types like int and double. But you can make arrays of any type. And remember, your classes that you define are actually user-defined data types. So if you have a circle object, remember we had circle object in the first module as an example. So when you have circle object, you can create an array of circles. And in this case, I've created an array of 15 circles. If you're doing the zombie chase game and you want to have a bunch of zombies chasing the player, create an array of zombies. There was a person that did one of those missile strike games a few years ago, and he created an array of missiles. So if you need to have a situation where you create a class and you need to have a lot of those in the class, you would just create an array of them. For the sheep-sheepdog game that we started out with this semester, if I wanted to have 3 sheep, I could create an array of 3 sheep. So the declaration creates a little holding place to keep track of the head of the array. The creation with the new keyword actually builds the array. And so here's an example of that. And I put a for loop in here so you can see how this works. So I've declared it up here. Now this is a variable, not an attribute, because I declared it inside of main. So I've declared it in here, but I didn't build the array yet. Then I actually built it, new double 100. So I built an array of 100 doubles. And you know that I built it because of the new keyword. But now they're all zeros. Now how am I going to fill this up with data? There's 100 elements. Well, this is where file I/O can be useful, but a lot of times random data is just fine, and so I'm going to fill it up with some random data. And this goes back to the discussion we had last week with the for loop. The for loop has our starting condition, stopping condition, and progress, and the only thing that changed here is the stopping condition. Look at this, I less than example array dot length. So almost always when you're using for loops, you're going to go through and walk through an array and do something to each element. And so rather than having to use a separate variable to store the length of the array or how big it is or anything like that, it's just array name dot length, and Java keeps track of that for you. And that's why in the for loops we almost always have this form. Int I equals 0, because that's the first array element, is the 0th. And then I is less than example array dot length. So the last value of I will be n minus 1, or length minus 1. and then I++, which gets me to the next element. And then all I did here is created a random value. Math.random gives you a value between 0 and 1 evenly distributed. Okay, so we're going to stop here and then go into methods for the next half of the lecture.